In this final example of the collections API, I'm going to show you an example of how to sort a list of integers and how to sort a string. And by what I mean by sorting a string, I'll talk about momentarily. But in this example, we're going to talk about how to sort things using priority queues. Okay? So this is actually part of the answer to one of your labs, or one of your lab questions. So let's see how many people actually watch this video. Okay? So what do we do first? Well, so let's first work on the sort method, which receives a list of integers, and we're going to sort them. We're going to return a new list with the elements in sorted order. Okay? So, I mean, this is reasonably straightforward. At least writing tests for it is. So let's just test the empty list. So sorting the empty list should, of course, get us the empty list. Sorting a list of one thing should get us the one thing back. Sorting a list that's already in sorted order should, of course, just return that list. Sorting a list in descending order should get us the sorted list again. And let's just create a bunch of random numbers. Let's maybe throw some negatives in there. And maybe even some duplicates, that's also fine. So what would this be? This would be, let's see, -5, -4, 0, 1, 2, 8, 8, 12, 34. I believe that's right. Okay? So, and we'll come back to test sort string in a minute. So let's do this first. So how are we going to do this? Well, we know that a priority queue sorts its elements based on the natural ordering of the elements. And again, for about the 40th, 50th time now, the natural ordering of integers is ascending order. So what we can do is put all the elements of the list into a priority queue and then pop them all out or pull them from the queue into a list. And that list will definitionally be in sorted order. Okay? And this is actually a really fast way to sort a list. In fact, it's one of the fastest ways you can sort a list. Okay? So if you're thinking about using something like collections.sort or something like that, then no, that's not right. So on your lab this week, when you're asked to sort a string, you better not use arrays.sort, because you will not be awarded points if you do. But in this case, the reason why that would also be disingenuous here is because we want to sort them. We don't want to use Java's built-in stuff to sort it. If we did, we would just call collections.sort, or something like that. We wouldn't be writing a method to do it if we didn't want to implement the logic ourselves. Okay? So let's implement the algorithm. So the first thing is create a priority queue, add all elements to the PQ. So in general, with these comments, I'd recommend doing that because I think it's just a good way to kind of get your head in the mindset of what you're going to do. So first, let's create a priority queue, and then we're going to add all the elements to the queue. So for every integer x in the list, pq.addx. And as we add elements to the priority queue, it's going to do some things under the hood that make it sorted. Okay? So we have that. Now, dequeue the elements, or pull the elements from the PQ into a list. So we're going to create a new list, and then we're going to say while the PQ is not empty, or while its size is not equal to 0, then we're going to add to the list the thing that we pull from the queue. And then we're going to return the list. Now, it's really, really important to not just do something like for int x pq. So you can do this and then just add x. This will not work the way you think it does. And the reason why is because when you traverse over a PQ, its order is not guaranteed. Like, the order that we specify is actually not guaranteed. The order, the natural ordering by a comparator the natural ordering imposed by the type or a comparator for a priority queue is actually not guaranteed when you traverse over it like this. It's only guaranteed to be that way when we actually remove elements from the priority queue. Okay, so we have to traverse it in this way. Okay, so let's run this, and all tests should pass, and they do, so we're very happy. Now let's use that same logic to test sort string. So what does this mean? So it means that we give it a string, and then we're going to sort the given characters in the string in ascending order. So let's just assume sorts the character of a lowercase string in ascending order. Okay, so what do I mean by that? Well, first off, and it returns a new string. So like, for example, if we give it the empty string, then of course it's going to return the empty string. If we give it the string A, it's going to return the string A. If we give it the string A, B, C, D, E, F, G, it's going to return A, B, C, D, E, F, G, because those are already sorted. If we give it the string G, F, E, D, C, B, A, we're going to give it, or it's going to return A, B, C, D, E, F, G. Okay? Because that's the ordered version. If we give it the string hello, then it's going to return E, H, L, L, O. Okay? Because again, this is the ordered version of the string. If we give it the string, let's say discourse, then it's going to return, let's see if I can do this right, C, D, E, I, O, R, S, E, U. Let's see. D, I, S, C, sorry, D, I, S, C, O, U, R, S, E. Oh, there's two S's, sorry. Yeah, so D-I-S-C-O-U-R-S-E. And there's only one E. I don't know why I put multiple there. Okay? But how are we going to do this? Well, we can do the same thing. We can first create a PQ of chars, and we can do that by doing Q character PQ equals new priority queue. We're going to traverse over the characters of a string. So there's two ways we can do this. One way is we can actually convert it into what's called a char array. Okay, but I don't see any reason to do this. Let's just do it the natural way of getting the indices of the string and then adding them, or getting the ith character and adding that to the priority queue. Okay, so we add the ith character to the priority queue, and then we're good. So now we're going to create a new string by concatenating the characters or the chars from the priority queue. Okay, so we're going to create a new string, set it equal to the empty string, and then we're going to return that new string. And then somewhere in between here, we're going to do some work for that string. Okay, so then again, we can just do, while the PQ is not empty, just do new stir plus equals PQ.poll. Okay, so, and this is going to say string concatenation slow. We don't care. So let's just run this and hopefully it all passes, and it does. Okay, so yeah, so this method, if you haven't watched this video, then well, then the people who are, you're probably going to struggle a good bit writing this method if you haven't seen this video. If you have seen this video, then great, you have one part of that problem on the lab already done. Okay, if you're not in C212, then you don't know what I'm talking about. That's fine. But if you are in C212 and you're watching this, then very good. I'm glad that you're watching this, and you can absolutely just copy this method verbatim and put it inside of your code. That's perfectly fine.